Today what we're going to do is we are going to do lesson 10.7 and 10.8. We are going to learn 4 different types of factoring. Okay, so I need you to pay attention. We're going to go through it as best as we can. All right, if you have any questions, I want you to make sure and I want you to ask those questions. All right. The first type of factoring that we are going to do is the difference of 2 squares. And this is example 1. I want you to write this down. I want you to actually write down the title, the difference of 2 squares. Okay, when you see the word difference, what does the word difference mean? Subtraction. I want you to write that over this word, right? Subtraction. Then, when I see 2 squares, it means exact square root. So, write that. So, we have a subtraction problem, and the 2 terms have exact square roots. Anytime I have the difference of 2 squares, it is always going to be 2 terms only. There'll never be 3. There'll never be 1. There'll never be 4. It will always be 2 terms only. So the first thing that I want to look for is I want to look for difference. Is it a subtraction problem? Because if it's not a subtraction problem, it's not the difference of 2 squares and I can't do anything with it. So we look, is the first one a subtraction? Yes, it is. So the second part of it is, does each term have an exact square root? Now, a lot of times, we call this method the tree method. And I'm going to show you why people call it the tree method. What are the 2 terms that make up the square roots of m squared? M and m. Write those down just like that. What are the 2 numbers that make up the square root of 4? 2 and 2. See how they look like little trees right there? And what that does is that tells us the exact square roots of each term. If you ever have the 2 numbers here that are different, like if you put 1 and 4, it's not right. You can't do that, okay? So let me ask you this. How many terms did we say it has? 2, right? It's missing that 3rd term, and it's the middle term that it's missing, the B term. The whole point of the difference of 2 squares is for that middle term to go away. Okay, so the signs that I'm going to use when I factor it, because here's our answer. This is how we write our final answer. We're going to do our 2 parentheses, like we always do when we factor. Whatever comes first in the problem, like in this case it's m, goes at the beginning of each, so my m and my m. Whatever is at the end goes at the end of each set of parentheses, so 2 and 2. In order to make a term cancel out, what would you assume would be the signs that we use? 1 positive, 1 negative. Exactly. The difference of 2 squares is always going to be 1 positive, 1 negative. It'll never both be positive. It'll never both be negative. It's always 1 and then the other. And you could put m minus 2, m plus 2. It really does not matter the order as long as you have 1 of each. So then let's look at the next one. First of all, is it a difference problem? Is it subtraction?
Yes.
Yes. What is the square root of x squared? X and x. What is the square root of y squared? Y and y. So, yep, because I was able to write both of them twice, I'm going to write x plus y and x minus y, just like that. Okay, the next one. Is it a subtraction problem?
Yes.
Yes. What's the square root of 25? 5 and 5. What's the square root of q squared? Q and q. Now, everybody look. What did they give you first, the 25 or the q? The 25. So, we must write the square root of 25 first. I cannot write q plus 5, q minus 5. That is wrong if you do that. It's going to be 5 plus q and 5 minus q. You say, well, that's not in standard form. I realize that. but the original problem that they gave us was not in standard form. So that's okay. It must be in the same order of the problem that they gave us. If it's not, it's wrong. Now, how would I check these if I wanted to check them? Foil, exactly. If you foil, you're going to get the exact same original problem. And then the last one, what's different about this last one is that first term has a number and a variable. So I just need to ask myself, what's the square root of 9? 3. What's the square root of q squared? Q. So it's 3q and 3q, which are my first terms. And then what's the square root of 64? 8 and 8. Just like that. So then it's going to be 3q plus 8 and 3q minus 8. So if I wanted to check, I could FOIL that out, and it would match the original problem if I did it correctly. So then the next example actually goes into lesson 10.8. So that was what we covered in 10.7. Lesson 10.8, what we are going to do is we are going to find the greatest common factor. Find the greatest common factor. Now, most of you should have already had at least some background information of this because you should have done it in pre-algebra. Greatest common factor is just the biggest number or variable that can come out of however many terms that you have. Okay? So what I want to do here is I want to look at the two terms that I've been given in the first problem. I want to look at their numbers first, 14 and 21. What is the biggest number that I can divide out of both of them? Joseph? 7. Very good. 7. Okay, so I'm going to put divided by 7 underneath it. I want you to do the same thing. Now, I need to look at the amount of terms I have. How many terms do I have? 2. Do all of those terms have the same variable? Do they? I mean, they might not have the same amount, but do they have the same letter? Yes. Okay. We're not looking at if they have the same amount. We're looking at if they have the same letter. Okay. They both have an X, which means there's a GCF of an X also. So this is how we know how many to take out. This is the easiest way for me to tell you. It's super simple. If you understand this, it'll be very easy. Look for the smallest exponent. What's the smallest exponent? 2. Squared. That's how many you take out every time. It'll never be anything different. So we're going to take out 7x squared as my GCF. Now, here's the number one mistake with GCF. People get the GCF right. They know what to take out, but they divide it out, and then it's nowhere to be found. Your GCF must be written. And where it goes is right here on the outside of parentheses. Your GCF goes outside, and our two new terms that we've divided by goes inside the parentheses. So this is how I do this. I want you to write this down. Divide the numbers subtract the exponents. If you write that down, then you'll always know what to do. Divide the numbers, subtract the exponents. So I'm going to do 14 divided by 7, which is what? 2. So there's my first number. And I subtract the exponents. 3 minus 2. How many x's am I left with? 1. So 2x. See how that's my new first term? Divide the exponents, divide the numbers, subtract the exponents. Then 21 divided by 7 is 3. So I put my minus 3 here. And then x squared over x squared, what happens there? Cancels out or subtracts and gives me 0. And what is any variable with a 0 exponent? 1. It's just not there. Okay? So this is my final answer right here. How would I check this problem? Very good. Distribute it properly. If I were to distribute that 7x squared, you would come up with the exact same answer. That's why I'm saying people who totally drop off the GCF, they forget about it, they just have 2x minus 3. Well, how could I ever check that? That would never check out to the original problem. Okay? Look at the next one. 11x minus 22. 11 and 22. What's the number that's the GCF? 11. Do they each have the same variable? No. The 11 has an x, but the 22 doesn't. So that means there is no variable GCF. It is just 11. So where does this GCF go? On the outside, and then we divide. 11 divided by 11 is 1, or we could just cancel it out and left with an x. You can write the 1 there, or you don't have to. It's up to you. Then negative 22 divided by 11 is 2 minus 2. There's my final answer. If I wanted to check it, I would distribute. 11x minus 22, yep, we know it checks out. Okay? And then the last one, they gave us 3 terms this time. We treat it just like we did the first 2 problems, but this time I've got 3 numbers, 6, 12, and 18. What is the greatest common factor of 6, 12, and 18? 6. You always want to do the biggest number that can come out of both of them. Let me give you a little helpful hint also. Your GCF will never be bigger than your smallest number. So like you couldn't look at that and go, oh, 36. Because 6 divided by 36 is not going to give you a whole number. 12 divided by 36. Nope. It's always going to be no bigger than your smallest factor. Okay? So we've got, or your smallest term, 6. We're going to divide everything by 6. Do they all have x's? No. 2 of them do, but the third one doesn't. And when that happens, we cannot take out a variable. They all must have the variable. So my GCF is 6, which I put on the outside. And then I'm just going to divide. 6 divided by 6, I'm left with x squared. 12 divided by 6 is 2x. And 18 divided by 6 is 3. Now, let me ask you a question really quick. Let's pretend for a second that that very last term that I divided by was 6. And at the end, I got 6 divided by 6. Would I just make that go away, or would I put a 1 there? A 1. Did everybody hear that? You should always end up in your parentheses with the exact same amount of terms that you started out with. So if you start out with 3 terms, you must end out with 3 terms, okay? If you don't, it's wrong. You forgot something, okay? So that's how we take out the GCF. Okay, so in the next example, I want everybody to take notice of what the instructions are, and I want you to write this down. Factor completely. And I was very nice, and on your notes right here, on your quiz and on your test, I put hint. Take out the GCF first, because this is a 2-step problem. What they're going to do now is they're going to see, do you know how to take out a GCF, and do you know how to factor? And they're going to put them together and make us use our brains fully, okay? So factor completely, anytime you see those instructions, you know it's 2 steps, take out the GCF first, then factor. So I'm going to look at this first set of terms that I have here. 4x cubed plus 20x squared plus 24x. We want to, obviously, take out the GCF first. So what is the GCF of 4, 20, and 24? 4. So I'm going to put a little division under each of these. Do they all have a variable?
Yes.
Yes. How do I find out what variable to take? Smallest exponent. So I have 3, 2, and 1. So which one am I going to take out? 1. So I divide everything by 4x. Where do I put that GCF? On the outside. So we put it right here. We can never, ever, ever drop the GCF. It must be in the answer, because we're not dividing it out so it vanishes. We're just dividing it out to move it to the outside. So remember, we divide the numbers, subtract the exponents. 4 divided by 4 is 1, or it cancels out. My advice to you is cancel it out. Don't write the 1, because you're about to see what we're going to do. 3 minus 1 is 2, so it's x squared. Then 20 divided by 4 is 5. X squared minus x is x. And 24 divided by 4 is 6. What happens to the x's there? Cancels out. Now, here's step number 2. Step number 2 is factor what you have left in the parentheses. So there's 2 different ways we can factor. Number 1 is that x method that we learned back on last week and then yesterday, where it's either the regular factoring or AC factoring, or the difference of 2 squares, the little tree method that we just learned in the other example. Let me give you a hint of how you know. You ready? It's super easy. If you have 3 terms, you're always going to do the x method. If you have 2 terms, it will always be the difference of squares. Never anything else. Okay? Now, is this going to be AC factoring or regular?
AC. Regular.
Regular, because look, do I have an A that I can see? No. Now, there is an A there. Technically, it's 1. But we don't do the AC factoring because we don't see it. So I put my positive 5 up at the top, positive 6 at the bottom. List the factors of 6. 1 times 6, 2 times 3. 2 and 3. Why did you choose 2 and 3 and not 1 and 6? Because they have to add to give me 5. What are both of the signs going to be? Positive. Now, watch this. You ready? We're about to write our final answer. The hard work is done. We must drop down the GCF because the GCF has to be in the final answer. So I just write 4x, and then I'm going to write how I factored what I had left in parentheses. And it's going to be what?
X plus 3.
X plus 2 and x plus 3. You say, well, how would I check that? There's 2 different ways. You can distribute this 4 to each thing in the first set of parentheses and then FOIL. Or you can FOIL these things right here and distribute the 4x. And you will get what the original problem is. All right, so let's do the next one. 45x to the 4th power minus 20x squared. So, like I said, factor completely. Hint, take out the GCF first. What is the GCF of 45 and 20? 5. Very good. How many x's can I take out? 2, because I'm looking for the smallest exponent. So we divide the numbers, subtract the exponents. So I'm left with, where does my GCF go? On the outside. 45 divided by 5 is 9. 4 minus 2 is x squared. 5 divided by negative 20 is negative 4. X squared over x squared cancels out. What type of factoring do I have to do now? Difference of squares. It's only going to be AC when there's 3 terms. Teddy, how many terms do I have? 2. That's why I know it's the difference of 2 squares. Also, look, what is 9x squared square root? 3x. What is 4 square root? 2. Okay. So then for my final answer, what do I do with that GCF? Write it on the outside. 5x squared. Then in parentheses, I'm going to have 3x plus 2 and 3x minus 2. Very good. Remember, it will always be opposite signs. It'll never be anything different. Okay, so that's factor completely. Take out the GCF first, then factor what we have left in parentheses. Okay, the last example that we're going to do today is called factor by grouping. I want you to write that down. Factor by grouping. Now, if you notice, in factor by grouping problems, we always have 4 terms. Never any more, never any less. It'll always be 4 terms. That's how I know how to do factor by grouping, because I've got 4 terms. What does the word group mean?
More than two.
More
More than three.
we're going to put things together. That's what group means. We're going to group them together. We're going to put things together. So what I'm going to do in factor by grouping is, because I have 4 terms and that can get tricky, we're going to put groups together. That way it's going to make it much easier for me. Okay? So this is how we group. Are you ready? We're going to take the first 2 terms and we're going to draw parentheses around them. So x to the 3rd power plus 2x squared. And then I'm going to group the last 2 terms, but I want everybody to watch. Watch where I write my parentheses. What did I include in the second set of parentheses? The addition sign. If you do that, you will make your life so much easier. Okay? If you include that sign, it's going to be very clear what type of GCF we're going to take out whenever we get to that. Okay? So now that we've grouped, what we're going to do is we're going to take out the GCF of each set of parentheses, one at a time. Okay, so we're making it a little bit easier on ourselves. We're grouping. Now GCF. What is the GCF of x to the 3rd power plus 2x squared?
1.
Well, there's a 1 technically, but what else do they both have?
X squared.
X squared, okay? Sometimes you do not have a number that's a GCF. Actually, let me take that back. Technically, you will always have a number that's a GCF, and it's 1, because 1 is the universal GCF. But when there is also a variable, we can just take out the variable and not write the 1. Now, you can write the 1 if you want to, but you don't have to. So my GCF is x squared, and where do I write that x squared? Outside parentheses. Divide numbers, subtract exponents. Well, we only have exponents. So x to the 3rd minus x squared is x. 2x squared divided by x squared is 2. The x's cancel out because x squared over x squared subtracts and gives me 0. Now look at the next term. I had somebody ask the question earlier, will there ever be a negative GCF? And the answer is yes. This is what we do, okay? We are going to look at whatever the sign of the first term is. Whatever the sign of the first term is what type of GCF I take out. If it's positive, I take out a positive GCF. If it's negative, I take out a negative GCF. So what type of GCF am I taking out of this one? Positive. That's why we include that plus sign right there, is it makes it easier for me. So what is the GCF of 3x and 6? 3. And I'm going to put plus 3 on the outside. Again, write that plus sign. It's going to make your life easier when we go to write our final answer. We divide. 3x divided by 3 is x. 6 divided by 3 is 2. Now I want everybody to stop. And I want you to look at your work. And I want you to look at my work. I've got 2 GCFs out here on the outside, and I've got 2 sets of parentheses. Look at what is inside those parentheses. It is identical. That is the whole point of factor by grouping. If you do not get the same thing in the parentheses, you did it wrong. If you got x plus 2, x minus 2, you did it wrong. If you got x plus 2, x plus 4, you did it wrong. Okay? You must have the same thing in both sets of parentheses. That's how we're going to write our final answer. Okay? So here we go. We're going to write the final answer. We are going to take the outsiders, x squared and 3x, and we're going to write them together in one set of parentheses. That's why I wrote the plus sign, so I would know exactly what to write right here. X squared plus 3. Everybody see that? Makes it easier. Now, what we did in factor by grouping is we took out the GCF to figure out what the groups had in common. What do they have in common? X plus 2. So that is our second set of terms. We don't write x plus 2 squared. We don't write it twice. We are looking for what they have in common, which is x plus 2, and we just write it the one time. Okay? And this is my final answer, just like that. That's why it has to be identical. What's in parentheses? How would I check this? FOIL. Okay. Let's do the last one of these. What's step number 1? Group. So here's how you know your 3 steps to factor by grouping. Group, GCF, group. Okay? So we group our first 2. We group our second 2. Now, GCF. Riley, what is the GCF of the first 2 terms?
1x squared.
Very good. 1x squared, or we can just write x squared. If you want to write the 1 there, you can. So we write x squared on the outside of parentheses. X cubed divided by x squared is x. 2x squared divided by 2x is 2. Now, time out. Everybody look. What is 36x in this problem? Negative. So whatever the first term is the type of GCF I have to take out. So what type of GCF am I taking out? Negative. What is the GCF of 36 and 72? 36. And I notice they don't both have x's, so I leave it just at 36. So I write minus 36 right here. And then I divide. Negative 36 divided by negative 36 is x. Negative 72 divided by negative 36 is positive 2. If I would not have taken out the negative GCF, I would have got negative x minus 2. And then it wouldn't have matched up. That's why you have to do it like that, okay? In order for them to match, that's how it works. Okay? So we group our outsiders together. X squared minus 36. And we look at what they both have in common. X plus 2. Now, before we box it in and say we're done, the joy of factoring is the fact that you are trying to get it in the most simple terms, the simplest terms that you can possibly get it in. So I look at my parentheses. Does anybody see anything that can be factored farther? X squared minus 36. What type of factoring is that? Difference of 2 squares. If you see that, you must keep going. You cannot stop until everything is as simple as it can possibly be. So what's the square root of x squared? X and x. What's the square root of 36? 6. So we're going to do x plus 6, x minus 6. And you say, well, what about this x plus 2? We just bring it down because nothing can be done to it. It is in simplest form. And box that in. So with factor by grouping, you can actually have 3 sets of parentheses. Okay? Now, how would you check that? We would FOIL the first 2, and then we would get our 3 terms, and then we would use distributive property on the last one, and you will get what you started out with. Okay? So that is our factor by grouping, factor completely, GCF, and difference of 2 squares.